Okay, so we will start today's lesson. Okay, today's lesson basically we will actually look at the reactions, okay, involving alcohol, okay, and as well as carboxylic acid. Okay, alcohol and carboxylic acid. So we will try to go through the questions over here, and then the part that we have will not be. I think the last part. Okay, I have 15 questions over here, and then the last part. I think there are 2 questions, which you need to go through yourself and answer and submit as your assignment. Okay, so rather than wasting time, okay, we will go on. Okay, for the first question, okay, which alcohol will react with acidified solution to produce a ketone? Now, what alcohol, okay, is it primary, secondary, or tertiary, will give you ketone? Frey?
Secondary.
Okay, secondary will give you ketone. So we need to find out whether which one is going to be secondary over here. So if I draw, okay, butan 1-ol, so butan 1-ol, so OH is here, and then 2,2, so this is going to be methyl, and then methyl. So this is going to be primary, secondary, or tertiary? Jody?
What's it?
The molecule that I draw over here, is it primary, secondary, or tertiary alcohol?
Primary.
Okay, primary. So we are looking for secondary. Let's look for the B. Okay, pentan 3-ol. So pentan 3-ol. Okay, and then 2-methyl. So this is CH3. So you can see that this is going to be one R group, another R group, secondary. So the answer is going to be B. Okay, and I don't want to waste time for C and D, but if you just go through it, okay, you will not get the secondary over there. Maybe we'll just try with one, yeah. Pentan 3-ol, so pentan 3-ol, and then 3, okay, methyl. Okay, you can see that this is going to be tertiary. Okay, so we are looking for the secondary. Okay, let's go for second question. Which alcohol has chiral center and can be oxidized to ketone? Okay, again, you see ketone. Ketone is going to be, if you look at oxidation, secondary alcohol. We are looking at secondary alcohol. At the same time, we are looking for chiral center. Okay, so for A, pentan 2-ol. So pentan 2-ol. Okay, so this one is going to be secondary. Okay, secondary. And then let's see whether they have chiral center. Okay, you look at this carbon. Okay, so it has one group, another one group, another one group, another group. Okay, so it has a chiral center. Okay, so it has a chiral center. The answer is going to be A then. Okay, but let's actually have a look at the wrong answers, B, C, and D. Okay, let's actually look at pentan 3-ol. Okay, pentan 3-ol. So this one is going to be OH. Okay, so let's have a look whether they are primary, secondary, or tertiary alcohol. So you can see here they are going to be secondary alcohol. But do they have chiral center? They have C2H5, they have C2H5. Cannot have the same group. You need to have 4 different groups in order to have a chiral center. So they do not have a chiral center. Okay, for C, 3-methyl hexane 1-ol. Okay, hexane 1-ol. Okay, let's draw. So let's say hexane 1-ol, and then 3-methyl 1, 2, 3. So CH3. So let's look at the first here. This is going to be a primary alcohol. Primary alcohol doesn't classify. I want secondary alcohol. Okay, so 3-methyl hexane 3-ol. Okay, hexane 3-ol. Let's say I'm going to actually use the same molecule over here. So let's say hexane 3-ol. Okay, 3-ol, and then 3-methyl. Okay, you can see that. Okay, this is going to be a tertiary. Okay, so we do not want tertiary, we want secondary. So the answer is going to be A. Okay, so let's move on. Okay, compound X produces carboxylic acid. So definitely it can be either primary alcohol or it can be aldehyde. Okay, because after oxidation, when you heat it under reflux, okay, they can actually give you the carboxylic acid. But they mentioned that compound X has no reaction with sodium metal. Now, which one of these two don't have any reaction with sodium metal? Victoria? Can alcohol react with sodium?
No.
Why alcohol cannot react with sodium? Okay, this one you read, yeah. Okay, have a look at the video that I shared to you yesterday. You have 4 videos. Okay, one of the reaction is alcohol. They react with sodium to give you hydrogen gas. Okay, hold on. Okay, so they actually react with sodium to give you alcohol. Sorry, they will give you hydrogen gas. Okay, so aldehyde. Okay, whereas under the carboxylic acid, they do not give you any reaction when it comes to sodium. So we are looking for compound X. So this one is going to be propanol. Okay, propanol will be the answer. So of course, it's not going to be ketone. Okay, we just did over here. It can be propanol, propan-1-ol, but primary alcohol. But do remember, alcohol, they do react with sodium metal. So the answer here is going to be A. Okay, the next question. If you have a lactic acid, it causes pain when it is built up in the muscle. Which region reacts with both OH groups in lactic acid? So if I write down over here CH3, CH, OH, C double bond O, OH. When they say OH in the lactic acid, one OH is going to come from alcohol group. Another OH is coming from carboxylic acid. So here they are asking which reagent can actually react with both of the OH group. It means can react both with alcohol and carboxylic acid. Now take note, acidified potassium dichromate, they do not actually, for example, when you react with acidified potassium dichromate, okay, carboxylic acid cannot be oxidized further. So definitely no. Okay, alcohol, yes, possible, because if you look over here, this is going to be a secondary alcohol. Okay, secondary alcohol. Now, secondary alcohol, okay, they do not also react with, secondary alcohol, they react with potassium dichromate to give you ketone. Now, ethanol, okay, ethanol, okay, do remember carboxylic acid, they do react with ethanol to give you ester, but alcohol do not react with alcohol. So, no, not that. Sodium, okay, just now we learned that alcohol react with sodium to give you hydrogen gas. Carboxylic acid is an acid, so definitely they will react with sodium to give you hydrogen gas. So that will be the answer. How about sodium hydroxide? Now take note, sodium hydroxide, only carboxylic acid will react with sodium hydroxide, okay? Because base and acid. But alcohol, okay, they do not react with sodium hydroxide, okay? We didn't learn that. It's only going to react with sodium, okay, not sodium hydroxide. So take note, okay? Is there any question up to now?
No.
Okay, let's move on, yeah? Now, which are the only structures formed when butan-2-ol is heated with concentrated H2SO4? Okay, so if you have butan-2-ol, this is butan-2-ol. So I'm going to actually heat them, okay, with a concentrated H2SO4. So this one, concentrated H2SO4 or concentrated phosphoric acid, okay, all these, another one, I think, aluminium oxide, okay, hot aluminium oxide. All these are going to be known as dehydration reagents, okay, where they can actually dehydrate. It means remove the water from the alcohol. Okay, so we can remove the water. So if you remove the water, so if you remove the water can be removed either like this, where you are going to get something like this, or the water can be removed in this form, okay, where you can get something like this. Okay, the double bond will be there. Now, when you here they say the only structures formed from this compound, okay. So if you look over here, CHH, okay, this one, okay, and then if you look over here, this is C2H5, and then there's another H over here. So this one, this molecule, we are talking about this molecule. And then you do have, okay, this molecule where you have C double bond C, and then H, and then CH3, and then H and CH3. Okay, this one is possible. But, okay, have a look at this second molecule. This second molecule is going to be a trans. Okay, you can also get a cis isomer. Okay, you can get the cis isomer. In this case, you cannot get any isomer over here. So this might not be the only answer. Okay, let's actually look for cis and trans. Okay, this is going to be, okay, trans. This is going to be cis. So this one, okay, will be this one, this molecule. Okay, if you look at the option C, okay, the option C, you have only cis, but there is no trans. Okay, cannot. This one they only have trans only. So here, okay, the fourth option, they have cis, okay, but they have CH3 and CH3 over there. No, okay, do remember when the carbon is attached by the same atom, same molecules over there, they do not exhibit any cis and trans. And then have a look, here is going to be CH, CH and CH3. So definitely this will not be the answer. Okay, definitely this will not be the answer. So the best answer is going to be B. Okay. Most of the time, the students will get confused. They will choose either A or C. Okay, just be careful. Now for 6, okay, this one is very easy. Yeah? This one you must memorize, okay, by now. Okay, primary alcohol, they will be oxidized, okay, which is going to be, what is the color of oxidizing agent before and after? Okay, so potassium dichromate, okay, here they say primary alcohol, there is a reaction, okay, there is a reaction. So if you use potassium dichromate, okay, the color will change from orange to green, orange to green. And then if you're using potassium manganate, it's going to be purple, will become colorless. Okay, so the answer is C. Very easy. Okay. Next question, number 7. Now, which reagent, okay, can be used to distinguish primary and secondary alcohol? Okay, have a note, be very careful with this. Primary and secondary alcohol, they can be oxidized. So if you use both of the oxidizing agent, no use, because both of them will be oxidized. Primary will be oxidized to become aldehyde, and then further oxidized to become carboxylic acid. Secondary alcohol, they will be oxidized to give you ketone. Okay, so no use to select A or B. Okay, so they will not be the answer. Now, the next option is going to be dehydration, followed by Br2. Take note, primary or secondary alcohol, they change. Okay, dehydration means they are going to have a double bond, okay, alkene. But after that, they have the reaction with Br2. Okay, so of course, double bond, they will react with Br2 to decolorize the brown solution of Br2 immediately. So both of them also will actually give you the results. Okay, so you cannot differentiate them. But if you look at the last option, oxidation. Now, if you oxidize primary, okay, primary alcohol, they change into aldehyde, then carboxylic acid. Okay, primary, they change into, at the end, they will form carboxylic acid. Okay, if you have secondary alcohol, they will change into ketone. Okay, then after that, they say followed by Fehling or Tollens region. Okay, Fehling or Tollens region. Now, if you oxidize, okay, I think for primary alcohol, they oxidize to give you aldehyde. And then after that, they give you carboxylic acid. Now, when I test this with Fehling or Tollens, okay, possibilities are there where, okay, if you have aldehyde, okay, if you have aldehyde, aldehyde will give you a positive results with Fehling, or it will give you a positive results with Tollens. But ketone will not give you a positive result with Tollens or Fehling. So we are assuming that primary is going to change into aldehyde. Okay, so this one is more towards the following chapter, yeah, the carbonyl compound. So the carbonyl compound, they say that, okay, the Fehling and Tollens, okay, they can actually work by identifying aldehyde compared to ketone. Okay, so here the best answer will be, you can actually use D, okay, as the best answer. Okay, the rest, I think A, B, C, D, A, B, C, you cannot actually use it to differentiate secondary and primary alcohol. Okay, now which alcohol may be oxidized to a product, okay, which reacts with a 2,4-diphenylhydrazine reagent, but not with Fehling's reagent. Now we are looking for alcohol that will be oxidized. This one, do remember, this one can detect any carbonyl compound. So it can detect either the aldehyde or it can also detect ketone. But okay, no reaction with Fehling's reagent. It means we are talking about ketone, because aldehyde, okay, they will give you a reaction with phthalate. So we are talking about ketone here, okay. So which alcohol can be changed into ketone? So it means we are looking at the secondary alcohol. So you need to find out which one from here is a secondary alcohol. So butan 1-ol, okay, butan 1-ol. So this one is going to be a primary alcohol, primary. Butan 2-ol, if you have OH over there. So this is going to be a secondary alcohol. Okay, so I'm looking for secondary alcohol. If 2-methyl propan 1-ol, so propan 1-ol, and then 2-methyl CH3 over there. So this one is going to be still primary. Methyl propan 2-ol, okay, so 2-methyl. So this is going to be tertiary. So we are looking for secondary. Okay, for number 9, okay, butane dioic acid may be synthesized, okay, in 2 steps from 1,2-dibromoethane, okay, ethane. Okay, so you are actually synthesizing carboxylic acid from halogenoalkane. Now, which reagent can be used for this synthesis? Now, have a look over here. They have only 2 carbon. Here, they have 1, 2, 3, 4 carbon. Now, can you tell me what is going to be the reaction that is available in chemistry where you can change 2 carbon and you increase the number of carbons? Okay, Frey?
KCN.
KCN, okay? Do not react with HCN. That is going to be for carbonyl compound. So we are looking at KCN. So any reaction that has KCN is the one that we are looking for. So step 1, you need to react with KCN, and what's going to happen is CH2, CH2, you get CN and CN over there. The next step, okay, it's going to be reaction with dilute sulfuric acid. Okay, dilute sulfuric acid where they will react with H2O and then H plus over there to give you the carboxylic acid. Okay, they will give you the carboxylic acid, which is going to be both of them. Okay, they change into carboxylic acid here and carboxylic acid over there. So the best answer over here is going to be C. Okay, this one is very important. Now, number 10.
Okay, we will continue with question number 10. Okay, earlier we were discussing about this question. Malic acid, okay, has alcohol group, and they are going to actually have 2 carboxylic acid group. And then they say that under suitable condition, which substance will react only with 1 OH group in the malic acid molecule. Now, if you look at the first answer, okay, dichromate, okay, the oxidizing agent will actually change the secondary alcohol that you have over here to ketone. But carboxylic acid, they do not get oxidized. Therefore, the answer is going to be A. Now, for sodium do react with alcohol. They do react with carboxylic acid, so they will not be the answer. For sodium hydroxide, okay, they will react with carboxylic acid but will not react with alcohol. But there are 2 groups of carboxylic acid over here, and they only want 1 of the OH group, so that will not be the answer as well. For PCl5, okay, PCl5, they react with alcohol, but this is actually outside of the syllabus, which is going to be carboxylic acid also will react with the PCl5. The OH is going to be replaced by the Cl. So this one, okay, they do react, carboxylic acid, they do react with PCl5, SOCl2 and so on. So therefore, okay, they can actually react with OH and then they react with the carboxylic acid group as well. So PCl5 will not be the answer. So this one is going to be, the answer is going to be A. Now for question number 11, okay, an ester with the structural formula of the following is heated with an aqueous solution of sodium hydroxide, and we want the 2 organic products of this reaction. So if I draw this molecule, so you have this molecule C double bond O and then OCH3, and then you are heating it with aqueous solution of sodium hydroxide. So what we are going to do is we are going to break this bond, and we are going to have CH3 C double bond O, and then the OH will come here, and then you have OH here, and then CH3. So you are going to have, okay, this one is going to be methanol, and this part is going to be the ethanoic acid. Okay, so that's going to be the answer. Ethanoic acid, okay, and methanol. So that's going to be the answer A. Okay, for the next question, okay, so if you look at question number 12, okay, compound X can be made from 2-hydroxybutanoic acid. So this is compound X. So if I draw 2-hydroxybutanoic acid, okay, butanoic acid, this is going to be butanoic acid, and then 2-hydroxy, so this is going to be number 1, okay, so carbon number 1, and then this is going to be carbon number 2, so 2-hydroxy, so this is going to be OH over there. And then, okay, they are going to actually what should be heated, okay, with if we look at the compound X over here, okay, if we actually try to break the bond over here, okay, this one you can see that this is going to be ester bond, and if I break the bond over here, I'm actually going to get, okay, a molecule for this side, okay, I'm going to get C double bond O, and then OH bonded to carbon, hydrogen, CH2, CH3, and then I'm going to have, okay, the OH here, and we can see that, okay, the same pattern, okay, will come over here where you are going to have OH, and then you have C, CH2, CH3, H, C double bond O, and then OH. So we can see that, okay, these two molecules, these two parts, okay, you can see some kind of esterification is happening. So what we are going to do in order to actually get this molecule of compound X, okay, we have to form ester, okay, we have to form ester. So what we do, the compound, okay, you need to actually reflux, okay, with concentrated sulfuric acid, okay. So you need to actually heat the 2-hydroxybutanoic acid, okay, this is going to be 2-hydroxybutanoic acid, it's the same molecule as this, okay, 2-hydroxybutanoic acid. So when you do that, okay, we are going to actually get the molecule, okay, the compound X, okay. So this one is going to be, we are going to have an esterification process, okay, that's going to be the condition that is required for this. Okay, for the next question, so you have pheromones, okay, pheromones are used by insects and so on. So they are asking what are the organic products, okay, when this particular molecule is heated under reflux with aqueous sodium hydroxide. Now when you heat this particular molecule, you can see that this is going to be ester. So when you do this one we are talking about hydrolysis reaction. So you are breaking the ester to the respective carboxylic acid and the alcohol. So the bond that will be broken is this part, and you are going to actually get C double bond O, CH3, and this is the part that the OH will come in, and then the remaining part is the alcohol group. So I'll just write down for you. Okay, this is going to be the carboxylic acid and the alcohol group. Now take note that this is going to be reacted with sodium hydroxide. Now sodium hydroxide, they do react, NaOH, okay, they do react with carboxylic acid, okay, but they do not react with the alcohol. So if you look over here, there is no reaction with sodium hydroxide, but you are not going to get just carboxylic acid alone, because the presence of sodium hydroxide will change this carboxylic acid into a salt. So you are going to get H3C double bond O, O minus, and Na plus over there. So you are going to get this molecule, okay, and this molecule. So we just have to look at the proper answer over here. So there is no salt, there is no salt. Okay, there is salt here. Okay, and then we have to look for alcohol. Let's see. If you're looking at carboxylic acid, okay, carboxylic acid, this is going to be the carboxylic acid. So this is going to be the salt. Okay, that's going to be the salt. So this will be the salt also. Okay, but this should not change into salt. So the answer is going to be this one, the OH. This is OH. So they just invert it. So 1, 2, 3, 4, 5, 5 carbon. So 1, 2, 3, 4, 5 carbon. So the answer is going to be C. Okay, for the next question, 14. So we have propanoic acid. Okay, so which starting materials can be used to synthesize propanoic acid? So basically, how do you get propanoic acid? Now you get propanoic acid, okay, if you have alcohol. So this one is going to be a primary alcohol. So we know that the primary alcohol can be changed into aldehyde and then further changed into carboxylic acid. So this one is possible. Okay, number 1 is possible. Now for number 2, this is going to be aldehyde. Okay, and we know also aldehyde, okay, will be further oxidized, okay, to give you carboxylic acid. So this one is also possible. And this is going to be nitrile. Okay, this nitrile, okay, when you actually react with a dilute, okay, dilute sulfuric acid, okay, you are going to change this nitrile into carboxylic acid also. Okay, so this one will be also the starting material suitable to give you the propanoic acid. So you have 3 carbons over there, very suitable. Okay, now so the answer is going to be all here. Number 15, when hydrolyzed with dilute sulfuric acid, which compound produce propanoic acid? Okay, let's actually look at it. So here, okay, when you hydrolyze with sulfuric acid dilute, so this is going to be CH3, CH2, C double bond O, O, CH3. Now this is going to be ester for number 1. So they are actually hydrolyzed with dilute sulfuric acid. So what's going to happen? This is going to be hydrolysis reaction will happen. So you are going to get you're breaking this ester into carboxylic acid and alcohol. So you have 3 carbon, and then this is going to be the carboxylic acid, and then you have CH3 and then OH, that's going to be the alcohol. So if you look at the carboxylic acid, this is going to be propanoic acid, 3 carbon. So this is possible. Okay, for the second reaction, okay, when you have the 4 carbon, okay, you have 4 carbon over here. When you do reaction with dilute sulfuric acid, what's going to happen? You are going to get butanoic acid. Okay, the reaction can still happen. The nitrile can still react with the dilute H2SO4, but you are going to get a butanoic acid with 4 carbons. So therefore, it's not going to give you the propanoic acid. So the third one, okay, if you have this halogenoalkane. So if you have a halogenoalkane, so halogenoalkanes, when you actually react with the dilute sulfuric acid, okay, will they actually give you propanoic acid? No. Okay, halogenoalkanes, they do not react with the dilute sulfuric acid. Okay, when they react with the acid, okay, what's going to happen? Okay, when you have a reaction, okay, like for example halogenoalkanes, okay, halogenoalkanes, there are few reactions, okay, involving halogenoalkanes. You need to remember, okay, the first reaction is going to be they can react with KCN. Okay, they can also react with sodium hydroxide, aqueous. Okay, they can also react with ammonia. Okay, so ethanolic. Okay, ethanolic. And then for elimination reaction, okay, for elimination reaction, what they do, you react with sodium hydroxide but in ethanolic condition. Okay, that's going to be elimination reaction for halogenoalkanes. So for halogenoalkanes, there is no reaction when it involves the dilute sulfuric acid. So no reaction. So the only answer is going to be number 1. Now, next question. Okay, this is going to be a structure question. So here they have mentioned that, okay, you have 4 isomeric ester with the molecular formula C7H14 and O2, and then they are used for artificial flavoring, okay, of fruits, okay, fruit flavor. So in each of the spaces below, write one or more of the letters A to D as appropriate. So they are asking which of the following compound can exist as optical isomer. Now, in order to exist as optical isomer, okay, we need to make sure that they have a chiral center. A chiral center is any carbon that has 4 different groups attached to it. So if you look at the carbon here, okay, this is not chiral center, okay, got CH3 over there. This one, this carbon over here, okay, they only have 3 bonds, so it's not suitable. This carbon, there's still 2 hydrogen attached to it, okay, 2 hydrogen, so they are not suitable. This carbon, there's still 2 hydrogen attached to it, not suitable. Same, okay, same. And then this carbon has 3 hydrogen attached to it, so they are not suitable, okay, they are not suitable. So A is not suitable. Let's actually have a look at the B. Okay, similar, this carbon has 3 hydrogen, okay, this carbon has 3 bonding only, not suitable. This carbon has 2 hydrogen, not suitable. Okay, this carbon, where else you are going to have 1 hydrogen, okay, this entire group is going to be different compared to this entire group, and then you have CH3. Okay, so in this case we do have a chiral center here for this carbon. Okay, so this is going to be the chiral center. Okay, for the rest of the carbon, this is not a chiral center, this is not a chiral center. Okay, let's have a look at, okay, C, not a chiral center, not a chiral center, not a chiral center, not a chiral center. Okay, but here this carbon, okay, we know that it is attached to this CH3 and then this CH3, and then there is going to be 1 H here, but because CH3 here is the same as CH3 here, therefore this carbon is not a chiral center. Okay, so in total we do not have a chiral center here for molecule for compound C. Now for D, okay, so let's have a look. Okay, no chiral center here, no chiral center here. Okay, here, okay, for here, this is going to be a different group. Okay, this is going to be CH3, there's 1 H here, and then a different group here. So this is going to be a chiral center. Have a look over here. Okay, this is going to be a chiral center. Okay, this is going to be a chiral center. The rest, not a chiral center, not a chiral center, not a chiral center. So in this case, okay, the one that has chiral center will be B and D. So I'll just put B and D. Now on hydrolysis, okay, which of the following compound produce a secondary alcohol? Okay, let's actually erase all this. Okay, which of the following they produce a secondary alcohol? Let's actually do the hydrolysis. The hydrolysis, okay, this bond will be broken, this bond will be broken, okay, bond will be broken, bond will be broken. So we are going to this part is the one that will give you the OH, so I'll just put it using a different pen. Okay, H here. So here the H will come here, and then the H will come here, the H will come here. So if you look at the carbon here, this is carbon, okay, we want a secondary alcohol. Okay, so the carbon attached to OH here, there's H here, and then there's H here, so this is going to be 1R group. So this is going to be a primary alcohol. if you look at the carbon here, okay, this is going to be CH3 1R, this is going to be another R group, okay, and this is going to be H. So this is going to be a secondary alcohol. And here, okay, if I have a look at C over there, okay, so there is one H, okay, so there should be another H here, 4 bonds, okay, and then this is going to be one R group, so this is a primary alcohol. Okay, so here the last one, okay, you have C, okay, so H, and then this is the R group, so this is also going to be primary. So they are asking for the secondary, so the answer over here is going to be only D. No. The next question. Sorry, the next question is here. Okay, the hydrolysis of this compound, okay, produces ethanoic acid as one of the products. State the reagent and condition needed for this hydrolysis. So basically they want the condition and the reagent. So in order to actually break, or in order to do the hydrolysis, okay, you need to heat under reflux. Okay, heat under reflux. Okay, and then when you do this hydrolysis, you can actually either use sodium hydroxide, or you can actually use the acid, okay, the sulfuric acid. Okay, all must be in aqueous. Okay, must be in aqueous. But here what's going to happen is you need to produce ethanoic acid. Now do remember, ethanoic acid, okay, they do react with sodium hydroxide. So ethanoic acid, let's say after you actually have ester, when they give you carboxylic acid, and then when they give you the alcohol, what's going to happen if you are using sodium hydroxide? Okay, the sodium hydroxide will not react with the alcohol, but they do react with the carboxylic acid to give you salt. So but here we want only the ethanoic acid. Okay, therefore you cannot actually use the sodium hydroxide. We have to use the second one, which is going to be the H2SO4. Now this H2SO4, okay, they are going to actually just change the compound into carboxylic acid and alcohol. So you are not going to have some other products, like for example the salt. So in this case you are going to get the ethanoic acid. So the best answer over here is the condition is heat under reflux, but we need to actually use the diluted, okay, diluted sulfuric acid. Okay, so it's diluted sulfuric acid and heat under reflux. So you are going to actually get this ester change into carboxylic acid and alcohol. Okay, the next question. Now, so for this question, okay, we have a series of reaction based on propan 1-ol, and then here they actually put, okay, you have an alcohol, and then this alcohol is changed into alkene. Okay, so you have this alkene, and after that this alkene, when you react with steam, okay, you are going to get this product. So basically what's going to happen when you react with steam, okay, with the catalyst, you are going to get CH3 and then CH. So the double bond is going to be broken, so you have H. Okay, so what maybe if I bring the H here, the OH and H, they are going to come, H will come here and then the OH will come here. So the double bond is going to be broken. So you are going to get an alcohol here, and after that the alcohol is reacting with HBr. Okay, so this one, what's going to happen is basically the OH is replaced by the Br. Okay, so we will have the CH3CH, and then Br will come here. Okay, so that's going to be V, and then halogenal alkane is changing into alkene. Okay, that's going to be elimination reaction. So this elimination reaction we have already learned must be with sodium hydroxide, and then must be with the presence of ethanol. okay, you heat them, okay, you are going to get that. Okay, and then for reaction 2, this is going to be alcohol is changing into carboxylic acid. So this one is a primary alcohol, so this one must be oxidation. So oxidation, you can use any oxidizing agent. So here, okay, let's actually go for the question itself. Here they say suggest a suitable reagent and condition for reaction 1. Now this reaction 1 is going to be changing a primary alcohol into alkene. So this is going to be a reaction that is going to change, okay, the alcohol to become alkene. So we are removing the water away. So this reaction is going to be a dehydration reaction. So in order to do a dehydration reaction, you need to have a dehydrating agent. The dehydrating agent, okay, over here for alcohol is going to be the dehydrating agent for changing alcohol to alkene. We have 3 actually. So you need to choose one. Okay, so one is going to be Al. I'll change the color here. Al2O3. Okay, it must be hot. Okay, or you can actually use concentrated sulfuric acid, or you can actually use concentrated phosphoric acid. Okay, so all this must be heated. Okay, must be heated. So suggest a suitable region and condition. So I'll just put one of the, maybe I'll just put concentrated sulfuric acid and then heated. Okay, heated. Okay, maybe I'll just give you heated under 170 degrees Celsius. Now write an equation, okay, for reaction 2. Okay, you have this reaction 2 as reaction 2. This is oxidation using oxygen O to represent the oxidizing agent. So here, if you just put CH3, CH2, CH2OH, so plus O, and we are going to get CH3, CH2, CO2H. Okay, so there is going to be one of the O. Okay, the one O will go and enter there, and then the remaining, okay, you are going to get, for example, if I just write it down here, CH2OH, so I'm going to get C double bond O, OH. So what's going to happen, there is additional one O coming in, but these 2 hydrogen, okay, what's going to happen to these 2 hydrogen, they are going to actually react with the they are going to change into water. Okay, they are going, so I cannot just leave my answer like this. Okay, they are going to give me water, but take note that the 2 hydrogen that escape from here, they will react with one with another O over here. So there is you need another one more O, so I'll just put 2 there. So now it's balanced. Okay, now suggest a suitable region and condition for reaction number 2. Okay, is an oxidation reaction. So let's actually just put heated under reflux with, okay, heated under reflux with concentrated sulfuric acid. Now give the structural formula of U and V. Now, so the U is going to be, we already wrote just now, so we just need to change it into structural form. So we just put C, okay, and then you have CH3, we have 2H, so maybe I'll just put H2 there, CH2. Okay, let me erase nicely. CH2, CH3, okay, followed by CH2OH. Okay, done. Now for V, okay, we have this molecule. So again, CH2, CH3, and then we have CH2Br. Okay, that's going to be the structural formula. Okay, the next question. give the structural formula done. Okay, this one done. Okay, refer to the previous one. Suggest a suitable reagent and condition for reaction 3. It's a elimination reaction. Okay, elimination reaction. So sodium hydroxide with the presence of ethanol and heat them. So I'll just put sodium hydroxide with ethanol and heated. Okay, that's going to be the answer. Okay, that's all. Okay, just actually revise. Okay, and I'll see you later. Okay, thank you.